Hello students, in this video we'll find matrix representations for projections and reflections onto a line. Let's consider the line. Y equals AX, okay? And so what I can do is I'm going to look at that line. Here's the x-axis, here's the y-axis, and then here's the line y equals AX. Of course, I can generate this by the vector y. I can think of this vector over here as the vector, if x is equal to 1, y is equal to a, right? And so, of course, what I can do is I can say, well, I plugged in x equals what? I plugged in x equals 1, and then y was equal to a. If this is a right triangle over here, then this length over here is just the square root of 1 plus a squared. So what I want to do is I want to look at this angle over here. This angle over here, I'm going to call that alpha, right? And so what do I know about alpha? Well, alpha can be any number of things. I know the cosine of alpha and the sine of alpha are, right? So the cosine of alpha is 1 over the square root of 1 plus alpha squared. And the sine of alpha is just a, over this an a squared obviously. A over the square root of 1 plus a squared. Excellent, just from basic trigonometry. Now what I want to do is I want to figure out a formula for reflecting a point over this line or projecting a point onto this line. So let's do two simple cases first. So let's recall what's simple. So let's recall the matrix 1, 0, 0, negative 1 takes a point xy and sends it to what? And sends it to x negative y. And this is reflection over the what? Reflection over the x-axis. Over the x-axis. And similarly, we have this thing over here. Takes xy and just outputs x0. So this matrix, so I'm going to call this R for reflection and P for projection over here, okay? So, and this is going to be projection onto the x-axis. Projection onto x-axis. Okay, so I have projections onto x-axis and reflections onto x-axis are really simple matrices. Okay, so what I'd like to do is I'd like to take our issue of reflecting over this line and projecting onto this line, and I'm going to first do the following. So I'm going to say projection, so reflecting, let's first do reflecting. So reflecting over y equals ax. What I first am going to do is I'm going to take this line and then I'm going to rotate it clockwise, so this corresponds to a negative angle alpha, by negative alpha and put it on the x-axis. Then I am going to do a reflection over the x-axis, then restore my angle alpha. So reflection over the line y equals x will be the same thing as doing a rotation matrix m alpha, doing a ordinary reflection over the x-axis, and first doing a rotation m alpha. We're here, what's m alpha? So here, recall that m alpha, so m alpha is what? Is cosine alpha, negative sine alpha, then sine alpha, cosine alpha. So in this case, of course, what does it become? I know exactly what cosine alpha and sine alpha are. I can fill in these things over here. So for us, this is going to be what? So our matrix M alpha has a specific form. And so what will this be? So this is going to be reflection. This is going to be our reflection over y equals ax. Okay? And so what will the reflection over y equals ax be? Reflection y equals ax is going to be m alpha cosine alpha. So let's notice over here we have lots of these square roots. So I have a 1 over square root 1 plus a squared, a with a negative sign over square root 1 plus a squared, a over square root 1 plus a squared, and then 1 over square root 1 plus a squared. And then our ordinary R, which is this matrix over here, which is 1, and then a 0, and then a 0, and then a negative 1. And then over here, we're going to have m of negative alpha. What happens with negative alpha? This thing with a negative alpha, the cosine is an even function, doesn't care. I can just pull out that negative sign, and the sine is an odd function, so these negative signs will flip over here. So what's going to happen over here is I'm going to write this as, I'm going to pull out the square root. I'm going to have a 1, a positive a negative a, and then a 1, and that's divided by the square root of 1 plus a squared. Now everything over here is a factor of 1 plus a squared, so I'm going to pull that out of everything. That's going to be 1 over 1 plus a squared. And then times what? Times 1 negative a 1, 1, 0, 0, negative 1, and then a 1, a, negative a, 1. Okay? So let's see what we get over here. So this is going to be a 1 over a squared, 1 plus a squared, and the matrix 1, negative a, and then a, 1. What we get over here, I'm going to get a 1, and then an a, 1, then an a, and then a what? And then a positive a, then a positive a, and then a negative 1. Okay? So all total, what's our formula? So our formula for reflection over y equals ax is going to be what? It's going to be 1 over 1 plus a squared. And then what? And then we have a 1 minus a squared, 1 minus a squared. And then we'll have a what? We'll have an a minus a. So over here we'll have a and then a plus a, that's a 2a. Down over here we'll have a 2a. And then the last entry over here we'll have an a squared and then a minus 1, a squared minus 1. So there's our formula for reflection. So we can write this, of course, in more compact form as 1 minus a squared over 1 plus a squared, then 2a over 1 plus a squared, and then 2a over 1 plus a squared, and then a squared minus 1 over 1 plus a squared. That is our reflection over the line y equals ax. I can do the same thing for projection, right? So for projection, well, I'll just basically replace everything with what I know. So we're going to have for projection onto y equals ax, we'll have a 1 over 1 plus a squared. Then we'll have this matrix over here, same matrix, 1, negative a, 1, and then just a 1, 0, 0, 0. And then a 1a, 1a, and then a negative a, 1. And so what's going to happen over here, what's going to happen is that this is going to turn into what? What will this matrix product over here be? This is going to be a 1, then an a, then a 0, then a 0. Then a 1, negative a 1. And then a 1a, and then 0, 0. So let's see what we get over here. So our formula for projection, so projection onto y equals ax is going to be 1 over 1 plus a squared times what matrix? Times a 1, and then a, and then a what? And then an a, then a squared. So that is the formula for projection onto the line y equals ax. 1 over 1 plus a squared, 1a, a squared. So we have formulas both for the reflection. So we have reflection formulas. So here are our reflection formula. These are reflections. And these are projections. So here are our formulas for projections onto the line y equals ax and projection onto the line y equals ax. Thank you very much.